Good morning, student. In this video, I'm going to explain how to calculate Hamming codes. Okay, so the Hamming codes can be calculated in three steps. So these three steps, which will be clearly, you will understand how to calculate this Hamming codes for a given code, right? So in the first step, for a given code, how many parity bits to be added need to be calculated by using the equation m plus r plus 1 less than or equal to 2 power r. In the second step, you have to find the places where this parity bits to be added for that code. That is given by 2 power n, where n is equal to 0, 1, 2, 3, 4. Okay. In the third step, you need to calculate the value of the parity bits which you have added for a code. Let's take an example 101111, right? So this is uh, I mean one example we are going to solve. Here, totally 7 bits are there, right? So in the step 1, as I mentioned earlier, it is m plus r plus 1 less than or equal to 2 power r. So we know where the m is 7, right? That means the number of bits. So 7 plus r plus 1 less than or equal to 2 power r, that is 8 plus r less than or equal to 2 power r. So we need to satisfy this condition. Suppose if you take r is equal to 3, so ultimately it will be 11 less than or equal to 8, where it is not valid condition. If you take r is equal to 4, so 8 plus 4 less than or equal to 2 power 4 or 2 power 4, so that means 11 less than or equal to 16. This is valid. So we need to add 4 bits for a given code, right? So as already mentioned, the places where these 4 bits need to be added is 2 power n, that is 0, where n is equal to 0, 1, 2, 3, 4, like that. So if you calculate that, the positions are 0, 1, 2, 4, or 0 will not be there, 1, 2, 4, 8, 16, 32, right? So here, let's see, this is the original data we have taken 10111011, right? So we need to add this as per the second step. We need to add those parity bits in 1, 2, 4, and 8, right? 1, 2, 4, and 8, where because where it is calculated based on 2 power n, that is 1, 2, 4, 8, 16, 32, like that. So in these places where we can add the parity bits which we need to find out, right? So I have placed this P1, P2, P4, P8 in this table, and the rest of the data I have taken into this table, like the 1, 1, 0, 1, 0, 1, right? 1, 1, 0, 1, 1, 0, 1. So then here, this is the table where if you fill with the parity bits that need to be find out. Okay, so in order to calculate this P1, P2, P4, and P8, so we need to follow a rule called odd parity or even parity. Either we need to follow either the odd parity or even parity. Odd parity means if number of ones is odd, the resultant is zero. Otherwise, the result is one. Okay. Okay. If you are following even parity, if the number of ones is even, then result is zero, or okay, if the result is zero, or otherwise the value is one. Let's find out the value of P1. P1 can be calculated because this is the first one, P1. So P1 can be calculated as like this: 1357911, right? 13579. That means you are considering first bit, skip second bit. Check one, skip one, check one, skip one. Like that, you need to follow. So where you can find like 1357911, right? So for P2, right? P2, if you see, we are considering 2 bits and we are skipping 2 bits. That means 2, 3, we are considering check 2, 3, skip 4, 5. Check 6, 7, skip 8, 9. Right? Then again check 10, 11. So 2, 3, 6, 7, 10, 11. Right? Coming to P4, we need from here you need to consider 4 bits 4, 5, 6, 7, and leave 8, 9, 10, 11. Again, you can, if there are more bits are there, you can consider from 12, 13, 14, 15. Okay, so here in this case we have only 4 bits 4, 5, 6, 7. And finally P8. P8 can be calculated from 8, 9, 10, 11, 12, 13, 14, 15. Okay, up to 15. Okay, so here we have only up to 11, 8, 9, 10, 11. Right. Now coming to P1, just to see, so P1 value we are going to find it. So let's put it as 0. Then third bit, if you see here, third bit here it is 1. And fifth bit it is 1. And seventh bit is 1, right? And ninth bit is 1, 11th bit is 1. So I have taken same this value. Let us see the here 1, the number of ones in this one, 1, 2, 3, 4, 5. So here we are following even parity. So here the number of ones is odd. That means five ones are there. So the resultant is 1. If it is 6 ones are there, the resultant is 0. Okay. But here we are having 5 ones. We are following even parity. That's why the result is 1. Next go to P2. P2 we already told check 2, 3, skip 4, 5 like that. So we here the finally what the bits you need to consider is 2, 3, 6, 7, 10, 11. Right? So take the values from the table. 2, 3, 2 by default is 0 and 3 is 1 and then 6 is 0, 7 bit is 1 and 10th bit is 0 and 11th bit is 1. So let's count the number of ones here in this series. 1, 2, 3. Here odd number of ones are there. So we are following even parity. So finally answer is 1. Let's come to P4. So P4 is 4, 5, 6, 7. Right? So let's take by default fourth bit is 0 and fifth bit is 1, sixth bit is 0, seventh bit is 1. Right? So here the number of ones is even because we have two ones, so the resultant is 0. Right? So finally P8, 8, 9, 10, 11. We have only 4 bits here because the data ends up to 11 only. So we have to consider 8, 9, 10, 11. So 8 bit is by default 0, which we are going to find out. And the ninth bit is 1, 10th bit is 0, 11th bit is 1. Here also we have even number of ones are there. So the resultant is 0. The final answer is 0. So then put all these values in this table, right? So we have placed P1, P2, P4, P8. So finally, this is what called the having codes. This is very easy. Okay. Hope you like this video. Thank you.